Alright, so in this lesson, it's finally time to plot our gradient descent. Here's how we're going to do it. The first thing is we're going to add two more variables. These variables will collect all the values that are being calculated within our for loop so that we can plot our algorithm's progress on the chart. I'm going to call the first one of these plot vals, and this is going to be our thetas array reshaped into a 1x2 array. So 1 row, 2 columns. This is where we're going to add on all the theta values that we calculate in the for loop. And then the second variable is going to be called MSE vals. And this is going to start out simply as our first mean squared error calculation from our initial guess. So it's going to be y_5, comma, thetas 0 plus thetas square brackets 1 times x_5. Now that we've defined our two variables and given them some starting values, I'm going to add a little comment. I'm going to say collect data points for scatter plot, because that's ultimately what we're going to use these ones for. Now, within our loop, what we need to do is append the new values to our NumPy arrays. So I'm going to use our old friends concatenate and append. Let's use concatenate on plot vals. So plot_vals is going to be equal to np dot concatenate parentheses, and then we need to supply two things. The first is that tuple that's going to consist of the old value of plot vals, so all the previous values that we calculated in the loop, plus our updated thetas array. So this is going to be thetas dot reshape parentheses 1, 2. And then outside of this tuple, we're going to have to specify the axis and set it equal to 0. What this line of code will do is it will take the existing array of plot vals, which is a 1x2 array, and it'll concatenate it with the new theta values, which we've reshaped into a 1x2 array. Now we need to capture our mean squared error calculations. So it's going to be MSE vals, and just to mix things up, I'm going to use np.append and accomplish the very same thing, namely append values to our array. So first I have to specify where I want to append the values to, and this is going to be the MSE_vals array. And then the second thing I have to specify is which values I want to append. So the values are going to be equal to the new set of calculations. So I'm going to call our MSE function, pass in the y_5 actual y values, and then I'm going to pass in the y hat values. And if you remember, for linear regression, this was theta 0, which was thetas square brackets 0 plus thetas square brackets 1 times x_5. And that's it. Let me press Shift Enter and try to run this. See if I've made any errors. No, so far so good. Now it's time to plot the thing. So in order to plot it, I'm going to use an existing cell that we've already made, copy it, paste it in, and then add the scatter plot to modify the code. Scrolling up, I'm going to take this cell right here, copy it, come down here, and then I'm going to paste the cell below. To add our gradient descent algorithm's progress, I just have to add one line of code, a scatter plot. So I'm going to do that on the axes. So ax dot scatter parentheses, and then I have to supply three things. I have to supply the x values, the y values, and the z values. So our x values on our chart were the theta zeros, and we've stored this in a variable called plot underscore vals, and we've stored that as the first column. So to select the entire column, I can add a colon, a comma, and then a 0 to select all the rows in column 0 within this array. And then for our theta 1 values, I'm gonna select plot underscore vals, and then I'm gonna choose the second column. So all the values in the second column. So these are all the rows. Once again, a colon to select all the rows at column index 1. And finally, we need the values for the z-axis. And this was our MSC underscore vals variable. And that's pretty much it. That's the key information already supplied. Now, in terms of sizing up our scatter plot, I'm going to choose 80 for the size of the dots. And in terms of color, I'm going to go for, I don't know, black. Now let me hit Shift Enter and see what this looks like. Now, if you're looking at this chart and you don't see any changes, the problem might not actually be with our code. The problem might be with our visualization. So I've chosen a black color for the dots, and we've got quite a dark chart. So let's change the color and also the transparency of our chart. So I'll set the transparency of the plot surface with an alpha value. I'm going to pass in an alpha argument of 0.4. Now let me hit Shift Enter and see if we can track our gradient descent algorithm now. Now this is already much more clear. Brilliant. Now, given that this is our crowning achievement for this lesson, I think we're going to have to style our chart in a different way. So I'm going to go with a psychedelic theme by changing the color map from hot to rainbow in honor of the final racetrack in Mario Kart. And take a look at our wonderful rainbow-colored half-pipe here. Brilliant. So we can clearly see our step size, which is initially large as we're far away from the minimum, decrease as we're getting closer and closer. And the interesting thing about our gradient descent here is that we seem to be reaching the bottom of this half-pipe, but there's still some way to go. The only thing is that the slope is so shallow that all the steps at this point are very, very small. So even though we progress very, very quickly to this point down here, from there on, we have to take many, many steps to get to the actual minimum. Now, all of this was a very, very technical section. We've covered quite a lot of mathematical topics, and we've really peered under the hood of what goes on in a machine learning algorithm. We've looked at various different cost functions, and we've reviewed some calculus, and we've played with an optimization algorithm by turning various knobs, including the learning rate, the starting point, and finally, even the cost function. So where do we go from here? Where do we go next? In the next section, we're going to return to do something a bit more practical. We're going to look at a house price dataset for the city of Boston in the United States. And we're going to get into the business of predicting how much a house is worth based on its characteristics. And the technique we're going to use is called multivariable regression. So congratulations for making it this far. I hope you're ready for tackling the challenges coming up in the next lessons. Looking out the window, I can see that the almost never-ending London drizzle seems to have stopped. So I think I'm going to take this opportunity to pop out to the shops and restock the coffee that's slowly running out here. See you soon.